Modern authentication describes newer, more secure methods of verifying a user's identity. Characteristics include standards-based protocols, OAuth 2.0, OpenID Connect, OIDC, Security Assertion Markup Language, SAML. Token-based security reduces the risk associated with credential theft. Strong encryption. Microsoft Entra ID, Microsoft's cloud-based identity provider, supports modern authentication methods and capabilities. Passwordless authentication. Windows Hello for Business. FIDO2 security keys. Password hash synchronization. The simplest way to enable authentication for on-premises directory objects in Microsoft Entra ID. Users can use the same username and password that they use on premises without having to deploy any other infrastructure. Supports single sign-on. Some premium features of Microsoft Entra ID, like Microsoft Entra ID Protection and Microsoft Entra Domain Services, require password hash synchronization. Microsoft Entra Pass-Through Authentication provides a simple password validation for Microsoft Entra authentication services by using a software agent that runs on one or more on-premises servers. The servers validate the users directly with your on-premises Active Directory, which ensures that the password validation doesn't happen in the cloud. Companies with a security requirement to immediately enforce on-premises user account states, password policies, and sign-in hours might use this authentication method. Key benefits of using Microsoft Entra Pass-Through Authentication. Great user experience. Users use the same passwords to sign into both on-premises and cloud-based applications. Easy to deploy and administer. No need for complex on-premises deployments or network configuration. Secure. On-premises passwords are never stored in the cloud in any form. Highly available. Additional agents can be installed on multiple on-premises servers to provide high availability of sign-in requests. When you choose this authentication method, Microsoft Entra ID hands off the authentication process to a separate trusted authentication system, such as on-premises Active Directory Federation Services, ADFS, to validate the user's password. The authentication system can provide other advanced authentication requirements, for example, third-party multi-factor authentication. Federated authentication. Effort. A federated authentication system relies on an external trusted system to authenticate users. Some companies want to reuse their existing federated system investment with their Microsoft Entra Hybrid Identity solution. The maintenance and management of the federated system falls outside the control of Microsoft Entra ID. It's up to the organization by using the federated system to make sure it's deployed securely and can handle the authentication load. User experience. The user experience of federated authentication depends on the implementation of the features, topology, and configuration of the federation farm. Some advanced security features make users' sign-in process more difficult. Advanced scenarios. A federated authentication solution is required when customers have an authentication requirement that Microsoft Entra ID doesn't support natively. Modern authorization, contemporary, flexible approaches to access control that go beyond traditional role-based methods. Context-aware and risk-based policies factor in contexts such as device health, user behavior, etc. or dynamically assess risk scores to grant or deny access in real time. Attribute-based access control, ABAC, leverage user attributes or resource attributes, data sensitivity, risk category, to enforce more granular policies. Policy-based management. Authorization decisions can be centrally defined and managed through high-level policies that are enforced across multiple services and applications. Dynamic and fine-grained entitlements allow for more nuanced permission sets, sometimes down to specific actions on specific resources, enabling least privilege more effectively. Data workloads. Ultimately, the purpose of access control is to provide security assurances for business assets, which most often take the form of business-critical data and workloads that provide business-critical services to customers, employees, and partners. Control and management planes. In order to manage an enterprise with multiple workloads and many forms of data, organizations need to establish consistency with a control plane. These are the centralized mechanisms that provide unified and consistent access control over resources. In a modern enterprise, these are closely aligned to zero trust principles and primarily composed of identity systems, identity directories and identity synchronization management systems, because of the richness of context on user access requests versus raw network traffic. The enforcement of access control policies is often more distributed, includes identity, network, application, data, and other controls. In some legacy environments where modern authentication protocols are unavailable, such as operational technology, OT, network controls may be used exclusively. Management plane. These are the centralized systems that enable IT administrators to manage and maintain these systems. These are primarily composed of management tools and security tools that are used across workloads. The tools may be hosted in the cloud or on-premises and are increasingly managing multi-cloud resources as well as on-premises resources. Access management is a key component of a zero-trust strategy to ensure that authorized people and services have access to the right resources in the right conditions. Enabling this requires multiple access management capabilities, including validating and measuring risk to ensure that attackers can't get unauthorized access to the organization's resource via common attack vectors such as password spray, compromised devices, watering holes, drive-by downloads, credential theft, and much more. This requires measuring user identity risk to protect against compromised accounts, passwords, authentication tokens, and other credentials through behavior analytics, threat intelligence, and more. Device risk to protect against access by compromised and vulnerable devices through integration with device management, endpoint detection and response, EDR, capabilities, and more. Middle policy enforcement and remediation ensures that these risk measurements are acted upon by a security policy engine that integrates the user, identity, device, and other threat intelligence signals into policy decisions that enforce the organization's policy on all access requests. Access paths, technologies, carry out these decisions via direct application access and VPN, and extend them to additional policy and monitoring via SSE, bottom, segmentation. Additionally, organizations can implement technology for user access and between applications, workloads that isolate them from each other for additional restriction of attacker movement. Microsoft Entra Conditional Access brings signals together to make decisions and enforce organizational policies. These signals include user or group membership. Policies can be targeted to specific users and groups, giving administrators fine-grained control over access. IP location information. Organizations can create trusted IP address ranges that can be used when making policy decisions. Administrators can specify entire countries, regions' IP ranges to block or allow traffic from. Device. Users with devices of specific platforms or marked with a specific state can be used when enforcing conditional access policies. Use filters for devices to target policies to specific devices like privileged access workstations. Application. Users attempting to access specific applications can trigger different conditional access policies. Real-time and calculated risk detection. Signals integration with Microsoft Entra ID protection allows conditional access policies to identify and remediate risky users and sign-in behavior. Microsoft Defender for cloud apps enables user application access and sessions to be monitored and controlled in real time. This integration increases visibility and control over access to and activities done within your cloud environment. Identity protection allows organizations to accomplish 3 key tasks. Automate the detection and remediation of identity-based risks. Investigate risks using data in the portal. Export risk detection data to other tools. Identity protection uses the learnings Microsoft has acquired from their position in organizations with Azure Active Directory, the consumer space with Microsoft accounts, and in gaming with Xbox, to protect your users. Microsoft analyzes trillions of signals per day to identify and protect customers from threats. The signals generated by and fed to identity protection can be further transferred to tools like conditional access to make access decisions, or fed back to a security information and event management (SIEM) tool for further investigation. Detect risk. Identity protection detects risks, threats of many types. Investigate risk. Administrators can review detections and take manual action on them if needed. Risk levels. Identity protection categorizes risk into low, medium, and high tiers. Access control policies can be applied to protect organizations when a sign-in or user is detected to be at risk. Such policies are called asterisk risk-based policies. Microsoft Entra ID Conditional Access offers 2 risk conditions: sign-in risk and user risk. Organizations can create risk-based conditional access policies by configuring these 2 risk conditions and choosing an access control method. During each sign-in, identity protection sends the detected risk levels to conditional access, and the risk-based policies will apply if the policy conditions are satisfied. For example, as shown in the diagram below, If organizations have a sign-in-risk policy that requires multi-factor authentication when the sign-in-risk level is medium or high, their users must complete multi-factor authentication when their sign-in-risk is medium or high. The example above also demonstrates a main benefit of a risk-based policy: automatic risk remediation. When a user successfully completes the required access control, like a secure password change, their risk is remediated. That sign-in session and user account won't be at risk, and no action is needed from the administrator. Allowing users to self-remediate using this process will significantly reduce the risk investigation and remediation burden on the administrators while protecting your organizations from security compromises. More information about risk remediation can be found in the article Remediate Risks and Unblock Users. Continuous Access Evaluation, CAE. What is it? How does it work? Token expiration and refresh are a standard mechanism in the industry. When a client application like Outlook connects to a service like Exchange Online, the API requests are authorized using OAuth 2.0 access tokens. By default, access tokens are valid for 1 hour. When they expire, the client is redirected to Microsoft Entra to refresh them. That refresh period provides an opportunity to reevaluate policies for user access. For example, we might choose not to refresh the token because of a conditional access policy, or because the user is disabled in the directory. Customers express concerns about the lag between when conditions change for a user and when policy changes are enforced. Timely response to policy violations or security issues really requires a conversation between the token issuer Microsoft Entra and the relying party, Enlightened App. This two-way conversation gives us two important capabilities. The relying party can see when properties change, like network location, and tell the token issuer. It also gives the token issuer a way to tell the relying party to stop respecting tokens for a given user because of account compromise, disablement, or other concerns. The mechanism for this conversation is Continuous Access Evaluation, CAE, an industry standard based on OpenID Continuous Access Evaluation Profile, CAEP. The goal for critical event evaluation is for response to be near real time, but latency of up to 15 minutes might be observed because of event propagation time. However, IP locations policy enforcement is instant.